So we need to prove that root 3 is an irrational number. So the method what we are doing now, it is basically method of contradiction. It dates back to history because it was found by a great mathematical legend Euclid of Alexandria. In his books of thesis, what he given was to prove there are infinitely many primes. He used basically this technique. So we are using the same method to prove root 3 is irrational number. So first of all, this is the method of contradiction. First, I am assuming that root 3 is a rational number. So for me, root 3 is a rational number. So by definition of rational number, we can say that a number is rational if it can be expressed in the form p by q, where p and q are integers and q not equal to 0. Here I am making some strong condition too. I don't have any common factors for this a and b. That means this a by b that cannot be equal to 3 by 6 because 3 and 6 there are common factor 3. In the similar sense, this can be equal to 7 upon 5, okay, because for 7 and 5 we don't have any common factor. Similarly, root 3 I am expressing in the form a by b. Now in next step, I am squaring this part. So we have 3 is equal to a square upon b square. From this I can make an equation 3b square is equal to a square. From this 3b square is equal to a square, we can conclude that 3 divides a square. Then we are applying the properties of prime. If p divides a square, then we have p divides a or p divides b. So here this implies 3 divides a, okay, because a square is of the form a multiplied with a. You can see that this 3, it's a prime number. So p divided by a square is of the form p divided by a into b, right? So here we have 3 divides a. So if 3 divides a, we have a is equal to 3c for some integer c. Next one, now we have a is equal to 3c, a is of the form 3c, okay. Now a square is equal to, if a is equal to 3c, a square is equal to 9c square, which implies, and we know a square was is equal to 3b square. So I am replacing my a square with 3b square. Now we have 3 divides b square, because 3b square is equal to 9c square. I can cancel out 3 from each part. We have b square is equal to 3c square, which implies 3 divides b square. If 3 divides b square, by the same properties of prime, I can say that 3 divides b, which implies 3 divides b. So if 3 divides b, that implies b is equal to 3 times k. So here a is equal to some 3 times c, b is equal to some 3 times k. What does that conclude? That says that they have a common factor c, but our assumption was there is no common factor, and our conclusion was there is a common factor. So our assumption that root 3 is a rational number, that is false. Root 3 is basically a rational number. So in fact, root 3, root 2, root 5, root 7, everything, they are all rational numbers. So we can do another one. Now we need to prove that root 5 plus root 5 is an irrational number. So here, this is a technique which we follow in higher mathematics too for doing algebra. So root 2 plus root 5, I am assuming this is a rational number. Okay, this is a rational number for me. So I can write this number as the form a by b form. Of course, b is not equal to 0 and they don't have any common factors too. In fact, on simplification, I can write this is something like this, a by b minus root 2, which is equal to root 5. So in the next step, I am squaring this part. So a by b minus root 2, which is equal to root 5. So a by b minus root 2 the whole square, which is equal to root 5 the whole square. So this is equal to, this is of the form a minus b the whole square. So by using our algebraic identity, we can say that a square minus 2ab plus b square, which is equal to root 5 the square, that is equal to 5. So a square by b square minus 2a by b root 2 plus 2, which is equal to 5. Now in the next part, I am taking this 5 to the side. So 5 minus 2 minus 5, which is negative 3. So I have a square by b square minus 3, that is equal to 2a by b root 2. Now I am simplifying this portion. So we have a square minus 3b square upon b square, that is equal to 2a by b root 2. Okay. So, okay, now we can cancel out b from both parts. So the remaining will be a square minus 3b square by 2ab, which is equal to root 2. But this is a rational number, and we know that root 2, this is irrational, because we have seen the proof that root 2 is irrational. But this is actually a contradiction. We cannot write an irrational number in the form of a rational number. So this is basically a contradiction. So we can conclude that root 2 plus root 5, that is not a rational number, it is basically an irrational number.